Hey guys, so I thought most of you wanted to see the presynaptic postsynaptic neurons. So I thought I would kind of run us through what a question like that would look like. So say, for example, I asked you to draw me a presynaptic postsynaptic neuron and tell me where certain drugs affect that synapse. So what you would start is drawing me, right, some dendrites, a cell body, down to the synaptic terminal. And then you would draw me another one, right? Down to, okay. So this one is the pre, and this one is the post, right? So then you need to start kind of filling in the features for me, right? So I'd have neurotransmitters in here. And remember, those neurotransmitters, they could be acetylcholine, Gaba, dopamine, serotonin. They could be anything, right? And then we know that the neurotransmitters lie on this presynaptic neuron, and then at the start of the postsynaptic neuron, you would have their receptors, okay? So these are the receptors. And then those are linked to ion channels, right? So we've talked about many a times these being sodium ion channels. Remember, when you open a sodium ion channel, you'll get a depolarization, and then when you open the potassium channel, you'll get a repolarization, right? So that gives you an action potential. Now, it doesn't have to be sodium, it could be something else, but for our purposes, we like sodium. So what else are we missing? We're missing some channels over here that allow the neurotransmitter to be released, and those are calcium channels, right? Calcium channels. And then you not only have sodium or ion channels here, right? These are ion channels. You also would have them over here, right? At this area is the axon hillock, right? That's where, so it's the same thing here, axon hillock. That's where action potentials are generated, right? So you generate some kind of action potential. The action potential travels down. It reaches these calcium channels, which cause the release of the neurotransmitter, which goes and binds, right? Which opens the sodium channel, giving you the action potential that will then propagate to the next player you have here, right? So this is the pre. This is the postsynaptic neuron. So say I give you a drug. So let's call it drug A. Drug A inhibits calcium channels. Okay? So what would happen? Well, if you inhibit a calcium channel, we'd mark drug A here, right? This is A. And then what happens? Well, if you can't activate a calcium channel, you'll never release the neurotransmitter, which means you will not have binding to its receptor, which means you will not generate an action potential. There will be no signal sent. So you would tell me that. You would tell me where, and then you would tell me what happens. Okay? So then let's say we have drug B. Drug B inhibits, let's say, the receptor. Okay? So drug B I would put right here, right? This would be drug B. So if you inhibit the receptor, you can still release neurotransmitter, right? But the receptor just won't work, which means, once again, the sodium channel or your ion channel won't open. You cannot propagate the signal. So once again, you'll get inhibition over here. Drug C, for example. Drug C would, let's say that it prevents reuptake. It prevents reuptake. Well, reuptake, remember, is recycling of the neurotransmitter back into its vesicle. So if you can't do that, what would happen? Well, you'd have to think it would just float around out here, right? And when it floats around out here, the only thing it wants to do is bind to this receptor. Well, if you have excess neurotransmitter and excess binding, you're going to have excess signal, right? So you would have a very excitable area down here. Okay, so that's kind of what I'm looking for. I'm looking for you to draw a pre and a postsynaptic neuron, and then tell me what happens with these drugs. So it might not be these. It could be, for example, it could be Gaba, right? Gaba is an inhibitory neurotransmitter. And remember, it doesn't just have to be pre and post. You can have regulatory neurons come up here, right? I could have regulatory neurons that come all over here. So say that they create an IPSP, an inhibitory, and then an EPSP. Well, remember we just sum those together, okay? We just add EPSP and IPSP and whatever the net result is. So I have more inhibitory signals here, so it's going to actually end up with an inhibitory signal. If I had more EPSPs, it would be an excitatory signal, right? This is called summation. Sorry, this drawing is getting really crazy, but you guys are probably used to these shenanigans by now. So it's called summation, right? So we summate what can happen here and what can happen here, right? The signals. So you could have presynaptic control, or I could have drawn a bunch of postsynaptic control, right? It's just basically putting together what happens, right? And so, for example, over here, this is 1, 2, 3 synapses. That's spatial summation. That's multiple. That's like everybody in the room yelling your name, right? Versus if I just had one over here and I just keep sending the signal and sending the signal and sending the signal at the same synapse, that's temporal summation. That's like one person calling your name. So I think that kind of covers presynaptic, postsynaptic control and kind of all the things that can happen in there. Hopefully that was helpful and you can kind of expect something like that for your exam tomorrow.